So my name is Zachary Sistrunk. I work as a software developer 3 at C Spire. My role is on the systems integration team, which many of you may know as middleware. We write the services that connect the front-end web and store clients to the back-end billing systems, provisioning systems, vendors, and so on. I graduated from Mississippi State University with a bachelor's degree in computer science, and I've been working at C Spire since I graduated in 2018. So as a part of the middleware team, we have the largest code base, but also the most responsibility when things break. And as such, observability is a very big part of what we have to be involved in. As a part of my role, I am the subject matter expert on Grafana and OpenTelemetry for C Spire, and that means I help assist the other teams with their own observability solutions, getting them set up in Grafana. And also, as part of that, I have made contributions back to both Grafana and OpenTelemetry. So, C Spire is a privately owned telecommunications company located in Mississippi. They are based out of Ridgeland. We have 3 lines of business. The wireless provides service to the entire state of Mississippi, as well as Memphis, Tennessee, and the greater Mobile, Alabama area. Our home services team provides fiber internet across Mississippi, Alabama, and parts of Tennessee. And our managed IT services provides IT to 47 different states. It's also the sole provider of VoIP and connectivity for all state universities in Mississippi, as well as the long distance and internet provider for all government entities in the entire state of Mississippi. So at C Spire, before we had Grafana, we had a variety of different services. AppDynamics was used to measure our application health. We had LogicMonitor to monitor our VMs, and Splunk was for our logs. But none of these services were very satisfying to use. AppDynamics is completely unable to handle Scala, which is our primary programming language. So almost all of our stack, the only metrics we had from it were JVM metrics, and we had no traces at all. Both AppDynamics and Splunk are very expensive software, and they don't connect in any way. We could not jump from metrics to a trace to logs. Trying to diagnose an issue usually involved us setting timestamps to the time of an alert to try to find the right thing in the logs. A lot of manual digging. On top of that, AppDynamics, their Java agent, very poor in performance. When we removed it from our services, our CPU usage dropped by a full 30%. We knew it was bad, but we didn't know it was that bad. And the support we got from them, just the fact when we asked about the traces and our inability to see into our Scala services and about their poor performance, their recommendation was to de-instrument our code. Specifically, de-instrument the com.cspire package, but that's the entire code base. There'd be nothing left. So at first, the first thing we thought about was trying to fix AppDynamics ourselves. Their Java agent had an API that we could have integrated with, and we would have been able to manually instrument the services to add in the traces that we were missing. But we decided against that when we realized it would lock us to a specific version of the AppDynamics Java agent. And AppDynamics had just forced us to move off of our own premises and onto their cloud. So an update to their cloud would have required us to go through and update every single one of our services to keep our monitoring in place. It was not feasible, and we had to have a replacement. The first replacement we actually looked into was Splunk. Splunk APM has application monitoring, but it did not take long to look into it. We were not impressed by its dashboards, and it was way too expensive for what we wanted from it. We looked into both Datadog and New Relic, but they were both cloud-only products, and at the time, with AppDynamics having just had a major cloud outage, cutting off all of our monitoring, we were very interested in staying on premises. The last one we looked at was the Elk stack. It met all the requirements and had its own premises version, but in the end, we decided not to go with it because it had a much poorer user interface compared to Grafana. So after looking into all of those, we finally ended up choosing Grafana to go forward with. The biggest draw was the fact that we could freely try it with its own premises version so that we could actually trial it out for a length of time before having to spend any money. That was important to us at the time because we were still locked in the AppDynamics contract for another few years. The fact it was open source, we could contribute back to it, and the excellent documentation that they have available, as well as excellent community support. But the most important thing was the Prometheus and OpenTelemetry standards. We found many, many recommendations saying that Grafana was the best UI if you use Prometheus and OpenTelemetry. And those are the two technologies that we had very quickly decided we wanted to use. On top of the free tier, we were looking to the future for when we paid for it. The enterprise plugins that it had available, we used almost every single one of them. Oracle Database, Jira, ServiceNow, GitHub, Salesforce. All of those are very important business processes that we would love to have the ability to monitor. And as I said earlier, being able to be on premises was a very big draw for us. And lastly, looks good to me. We love the naming scheme. Not only the fact that it actually makes a common phrase, but L for logs, G for graphs, T for traces, and M for metrics. You gotta enjoy a clever naming scheme. So, how we went forward with implementing Grafana. We first started by installing the full open source stack. We set up instances of Loki, Grafana, Tempo, Mimir. At this time, Pyroscope did not exist, so profiles were not a consideration, but that is something we are looking at now. But we then created a proof of concept by updating 3 to 4 of our largest services. So we use Spring Boot, and we were able to update Spring Boot to just automatically expose a Prometheus metrics endpoint. And at the same time, we attached the OpenTelemetry Java agent to automatically collect all the traces that we needed. And using these and this proof of concept, we were able to get our data into Grafana fairly quickly and start creating dashboards using real data instead of having to use a demo environment with stuff that we didn't recognize, didn't know what we were looking at. At the same time we were configuring this proof of concept, we also configured our Grafana agent instance. We have standard locations and standard API paths across our stack. And thanks to that, we were able to create a generic agent configuration file that was able to find all of our services without us having to modify every single service beyond adding the endpoint itself. So one of the big parts of AppDynamics that was a problem for us was every single service had to have a unique ID. And so every single service, anytime we spun up a new virtual machine or added a new microservice, we had to give it a unique ID for AppDynamics to be able to differentiate it. That was not a problem with Grafana. Agent later got migrated to Alloy, And so we updated our config file accordingly, and we still use that today. After our proof of concept was fully tested and functional, we configured our automation platform, Ansible, to be able to deploy the entire Grafana suite of files to our virtual servers at once. This included Grafana Alloy, the OpenTelemetry Java agent, both of their config files, and later the OpenTelemetry extension jar, which let us customize the metrics and traces that OpenTelemetry produce. This deploy job allowed us to push out changes in only minutes, and we would make a change to our config, start off the job, and within 30 minutes, every single virtual machine we had was fully updated to the latest version. Once our team got more in depth, we started expanding to the other teams in IT. We trained them on how to build dashboards, what the data meant, how to get their data into Grafana, and let them poke around to create dashboards with their data. We held, for a little while, there was weekly training sessions with at least one member of each other team in the department, and we still have a group chat in our teams where anybody that has questions can ask us to get help. And at the same time, the systems integration team continued to expand that proof of concept to the rest of our services. It took, well, there's a timeline slide later, but it took a little while to get all of our services because we rolled them out in batches. But in under a year, our entire test environment had been migrated into Grafana. So when we started, we wanted to stay on premises. We did not want to use a cloud product. The problem is, on premises is hard. Maintaining a Grafana stack practically takes an entire full-time position, and that is a resource that we did not have. As we started pumping more data into the stack, we started running into stability issues because it couldn't handle the amount of data we were handing to it. And I know there were probably ways to configure it to be able to handle it, to tune some config settings, but at the same time, we were still working other projects, and we were not able to just dedicate days to tuning the on-premise instances, so we just kept it running as best as we could. And expanding it was also difficult because we are not containerized. So having to expand it meant spinning up a new virtual machine, getting the binaries installed, getting SSH keys set up, moving the config files, having to modify the config files on every other server in the cluster to add this new server so they all know it exists. So we had discussions with our sales team, and they recommended that we move to cloud. And we were hesitant. We had problems with cloud, but we decided we'd at least look into it. And we were honestly blown away by what we found. The features that are made available in cloud are tremendous. Application observability, K6, Grafana IRM, nowadays fleet management. All of these are things that were not available even in the paid enterprise version, which is what we were trying to buy. But they all looked so useful that we couldn't pass them up. And they gave us a price comparison between enterprise and cloud. I mean, the cloud, it was a bit more expensive on paper, but that paper didn't include the cost of maintaining the on-premises equipment. Like I said, it required basically a full-time position. If you add a developer salary on there, cloud was cheaper. But it really was a no-brainer in the end, and we do not regret that decision. So this was our timeline. We started off in January of 2022 investigating, and it only took us 3 months to make the final decision to use Grafana. and only another 2 months after that to have the full stack installed. And our proof of concept was done by July, although we were working on that at the same time as we were setting up the stack. And after the proof of concept, we continued upgrading our services through the next 9 months, and that's around the time we started communicating with our sales team to purchase Grafana Enterprise. A year later, we finally launched Grafana Cloud. Only a year after the proof of concept, systems integration team was fully migrated into Grafana. And then only 2 years after the initial proof of concept, the entire apps dev department was 95% of the way there. We only had a small handful of hard-to-update legacy services left over. And this 2-year timeline, it's even more impressive when you realize that we did not have a dedicated project to do this. This was being done by developers alongside their normal day jobs of other project work, adding new features to our stack, and so on. I'm very proud with the work that my team and all the other teams in our application department pulled off in getting all this set up. So to show the scale of our environment, in our production services alone, we have over 1,000 virtual machine and microservice combinations. Across all 4 environments, development, integration, test, and production, we have multiple hundreds of virtual machines, multiple hundreds of microservices. The combined combinations of those make up multiple thousands of individual services spread across 6 separate application development teams. And like I said earlier, in AppDynamics, each one of these had to have a unique ID and had to be manually grouped into applications and tiers. But all that manual grouping goes away with Grafana's label sets. The ability to define labels and have the combinations of labels be what you filter on. We have one label for instance and one label for service. And then the unique ID is just the combination of those 2 labels. And we don't even have to configure that because the instance is pulled from the server's host name and the service is pulled from the service's code. It's just already there. And on top of that, Grafana alerting allows us to create a single alert rule that's able to pick up every single combination and alert when any one of them goes wrong. And when that alert is fired, those same labels allow us to know exactly which team it needs to be routed to, which we can route to directly to their phone through Grafana OnCall. It's a much smoother process of diagnosing and figuring things out. So there's a few more slides showing screenshots. So I know they're a little bit hard to see in the light in here, but this is an overview dashboard that we've created for our VMs. It's a table that has its uptime, the CPU stats, the memory stats, the disk stats, and the network stats. At the top left is a list of currently firing alerts, and the top right is a list of quick links to other important pages in our Grafana instance. So this is our landing page. This is what everybody sees when they first log into Grafana. And it just shows the quick information that they can need at a glance. And you can actually see one of our servers in this screenshot is currently highlighted red because it is at 90% memory usage. So we know we need to add a few more gigs of RAM into that service. Java may be convenient, but it is very memory heavy. One of our favorite parts of moving to Grafana and one of the big selling points was traces. Full end-to-end traces powered through the OpenTelemetry Java agent. We get wide visibility, the ability to trace a single request that goes through multiple applications and teams. This trace in this screenshot goes through 4 different teams and I think 12 different services, if I remember correctly. But it's not just wide, it's also deep. Inside each service, we can go all the way down and see the exact SQL calls that we call into the database for, the exact Redis commands that are used to retrieve the cache. It's more data than we ever had in AppDynamics, and it makes it extremely simple to find exactly how and when something breaks. And traces, because of OpenTelemetry, they're very customizable. You can integrate your services with the OpenTelemetry API to create your own traces and metrics. But the biggest and most important part about this is Grafana Cloud's application observability. Application observability takes those traces and generates metrics based off of them. And those metrics give you request, error, and duration metrics for all of your services just automatically based on the actual traces. And you can see them all in this overview, which again, I know it's kind of hard to see, but we have the nice little spark lines showing us our request rates, our average durations, and the error rates. But you can then click into any service at all, and see all those details down to an API by API basis, as well as seeing the upstream and downstream services from the service you're looking at. So, for example, this screenshot, I believe, came from our billing services platform, which upstream is our customer services and downstream is our billing system. So if we're seeing slowness in the stack, usually the first place we look is this service. And 9 times out of 10, it's because there's slowness coming in from the billing system layer. And we can see that in both the API durations. The P95 is starting to trend above that upper anomaly bound. And if you look in the downstream services, you can see that same pattern following in the downstream service. And click down into that and see what's downstream from it to find the actual root cause of any slowness. This feature was what finally 100% sold us on moving to cloud, because this is something that was not available on premises. As for what's next for us, we plan on continuing to move forward with more cloud features, such as Grafana Asserts, which is going to be an evolving on application observability. As we are starting the process of containerizing our services, so we're going to be using Kubernetes observability. We're working with our front-end teams to get them to integrate the JavaScript Grafana Pharaoh library to extend those traces even into the browser. And we plan on moving more into Grafana IRM. We already use alerting and on-call, but there's incident to play with as well. And that has a big chance to integrate with our ServiceNow instance. We also plan on, as I said earlier, using the OpenTelemetry API to create custom metrics and traces. And these are going to be traces. We have an order processor, and we can see how long it spends in each individual step. And we can add in an error happened in this step right here. And we can generate metrics from those traces. Our sales data, we can insert into our payment stacks to track payment rates, our account stacks to track churn rates. All data that would be very valuable to the business that we can just make available directly from our applications instead of them having to build reports off of a database like they do today. And we also plan on expanding Grafana to more teams outside of our IT department. At the moment, our network team, they are the team that manages the cell towers and the fiber system. They are interested in seeing if there's a way to use Grafana to monitor the network, to get network stats and alerts when something goes down. That, with managed IT being the only provider of government internet in the state, and with C Spire being, I don't know for certain, but I believe we are the biggest wireless carrier in the state of Mississippi. Those kind of stats, being able to get proactive alerting on those would be a big deal for our customers. But after network, our reporting teams, the sales and marketing teams, we can put in the metrics for payment stats. We can put in the metrics to show what items sell the best. We can put in metrics to see what kind of emails we send out so the marketing team can see click-through rates. There's so much power in how customizable Grafana and OpenTelemetry are. And that's something that I am really looking forward to being able to investigate more.